Alright. Okay, so last week we were at power, and then also I told you in under 4.1, I told you all that we have to do energy transfers, conduction, convection, and radiation. That part we didn't do under 4.1. So then, without doing that only, we went to 4.2, where we did the other questions, right? That's what happened. No? So here under this today's class we'll be doing this thing. In today's class we'll be doing finishing the lesson number 4 by completing conduction, convection, radiation. And there's one more thing that you have to know called energy resources and comparing energy resources. So that is a very small part that also I'll give to you. Okay, so today we'll be finishing the 4th lesson. Okay, so then once lesson 4 is over, whatever the test that you have in the end of November, that should be fine, because on the next day we'll be doing papers. And there's one more announcement that I have to make. I won't be able to have the class on next Sunday, right? I'll have to like go this place on Saturday, and when I'm coming back it will be like 10 a.m. in the morning Sunday. So we'll have to figure out an extra day for that as well. Okay, so we'll see. Right now, write down. So we finished power, we related these things to power. Write down conduction, convection, and radiation. The topic conduction, convection, and radiation, that is the main topic. So under that, first of all, write down conduction. Right, write down conduction under that and listen up. So what is meant by what are these conduction, convections, and radiations? They are ways to transfer heat. Okay, they are ways in which heat can be transferred. So you already know heating is a mechanical pathway of transferring energy, right? So conduction, convection, and radiation, they are the 3 ways which comes under heating on how this energy is transferred. Okay, so under conductors, under conduction, so it's not conductors, it is conduction, it is the transfer method, conduction. So under conduction, tell me, what are the energy transfer pathways? How is the energy transferred? Under conduction, how is the energy transferred? Energy is transferred through conducting material, something called conducting material. Okay, so what are these conducting material and what are non-conducting material? What are conducting material? What are non-conducting material? Conducting materials mean materials that transfer heat. So in this lesson, this is related to the heat, no? So in this lesson, conductors mean materials that transfer heat. However, in the electricity lesson, there are something called electrical conductors. They will help to transfer electricity. Okay. So here, conduction, there are 2 types of these things, materials. There are conductors. Here conductors is heat conductor, materials which can transfer heat, which can let heat travel through. So for example, iron, if you keep one end of a iron onto a fire top, on a fire, right, light a fire, keep one end of a iron rod to a fire, and then you will feel the heat in the other hand side, in the other corner. That is an effect of this conduction. Conductors are one set of parts, materials, and then there are heat insulators. Insulator. What are insulators? Materials which do not allow the traveling or the conduction of heat energy. So under conductors, actually, under conductors, tell me some examples for these conductors. Conductors transfer heat. They are these things. They are used to transfer heat. So what are known as conductors? Some examples. We've got iron. What else? Can you tell me? Generally, conducting material like good conductors. Sorry, metals. Yes, correct. Iron is a metal. Most of the metals, all metals, we can say. So instead of iron, metals. It's easier, no? What else? So metals are conductors. What do you think? What else? Most of the metals, right? Aluminium, iron, conduct. Those are conducting instruments. They are conducting materials. What are insulators? Insulators means materials which do not conduct heat. Like monother. Rubber doesn't conduct heat. What else? Why wood? Polythene. So the thing is, if you keep wood on fire, it will burn up, right? Polythene also, it will like melt. Therefore, they can't be used as conductors. Okay, so keep that in your mind. So those are the things that you need to understand here. They are conductors. How do these conductors transfer energy? So inside a conductor, don't write this down yet, okay? Inside a conductor, you have to know if this is a, let's say I'm drawing the cross section of a metal. There are, what have we got? We have got the particles of that metal, right? We have got those metal particles inside. Look. So if this is, if I were to draw it like this, they will be actually much more closer. They need to be much more closer to each other, right? Because it is a metal, no? If it is a liquid or a gas, it will be a little bit more spread out. If I am giving heat, if I am giving heat from the left hand side, heat, what can happen? If this is a conductor, gradually this heat would be transferred from this point to this point. So this is point A, this is point B. Heat will be transferred from point A to B. How will it happen? Listen closely. It will happen by oscillating the particles side by side. So when the heat is coming here, initially the particles in this side, the particles which are here, they start to vibrate up and down, side by side. Okay, there's no specific direction, random motion, that is what you call. Then because these particles start to oscillate, the next particles, the particles which are next to it, like neighbors la, and they start to oscillate as well. So likewise the oscillation will continue till B, and then finally the heat will go out. Heat, if we stop providing the heat, after some time it will be lost to the surroundings. But if I continue providing the heat from this side, it will retain. Okay, so keep that in your mind. But remember, when this is happening, may side swelling, from there the heat can go out. Okay, their energy can go out. Keep that in your mind. Okay, keep that in your mind. Right, now first of all, I need you to write down this thing. So I'll send you an image. Okay, I'll be sending an images. I need to write down this thing. So under conductors, before writing down anything, write down what I'm saying. First of all, before drawing anything. Under conductors, you write down how heat is transferred, how heat energy, okay? So heat means heat energy, okay? How, under conductors, write down how heat energy is transferred, how heat energy is transferred by the oscillation. Oscillation means vibration, okay? This is how you draw oscillation. By the oscillation, by the oscillation, by the oscillation, see, this is the oscillation. By the oscillation of particles in a conductor, in a conductor, by the oscillation of particles in a conductor is known as is known as is known as conduction. conduction. Okay, right. Now, Senoli, I've sent the image of this to the group. You write it down. I'm going to erase this. So convection. Next, we have convection. So you have write down what's previously what we have done. So convection means the main way thermal energy is transferring through liquids and gases. Okay, convection means the main method energy is transferring or heat is transferring through liquids and gases. Alright? Okay, so under convection, first of all, you write that down. Convection is the main way. Convection is the main way that thermal energy. Convection is the main way that thermal energy is transferred. Convection is the main way that thermal energy is transferred through liquids and gases. Now remember, convection does not occur in solids. Keep that also in your mind. So convection, we can't just quickly go over convection like conduction. Okay, so therefore under conduction we wrote a small note, but under convection we have write down the procedure of how convection is happening. So now you imagine there is a fire pit like this. So these are logs, like we have to keep logs, to make sure the firewood burns. And firewood, this is the fire, right? This is the fire. So this is how the fire would look like now. This is the fire. Fire. Okay. Right. Now when there's a fire like this, what happens? So there is air all around this, okay? This is not only limited to the whiteboard. Right? Keep that in mind. You have to understand air particles which are initially above it. In a fire, through convection මේ උඩ part එක විතරයි රත් වෙන්නේ. But then you might ask, when you are around a bonfire, you feel this heat which is around as well. මේ surrounding part එකේ ඉදි දැන් අපි වටේගෙන ඉන්නේ fire එකේ. We are not on top of the fire no. You might ask, why aren't we feeling that heat? So what is the reason? We are getting heat to the surroundings through something called radiation that we are going to learn next. That means after this. However, how we get heat from convection is only from the top. Convection heat and උඩට විතරයි. එතකොට air particles which are initially here, right at the top of the fireplace, would start to heat up. When an object heats, you should know one thing. What is it? What happens to the volume? When an object heats up, what happens to the volume? Its volume is going to increase. When an object heats up, its volume is going to increase. Now what happens? When the volume increases, can you recall the equation? Density equals mass over volume. This is the equation that you get for density. No? When the volume is increasing, what happens to the density? The density decreases. Then when the density decreases, what happens? The gases which are right at the top of the fireplace, they'll go more up. They'll go further up because their volume decreases, their volume increases. Density decreases, they'll be less dense. They'll go up therefore. The particles which are comparatively cold, they may go comparatively hotter than ones which are high above, no? Because they are right on top of the fireplace. The particles which are on top, because the hot ones are going up, no? The cold ones which are at the top, they are going to come down. So the hot particles are going up like this. When the mehemano up, the cold particles are coming down like this from here. Then the cold particles are again going to get heated in the same procedure. Their volumes are going to increase their density is going to decrease. Because their density decreases, they are going to go up again. This motion and this motion, Metin, can you see I have drawn these arrows? These are called conventional currents. Convectional currents කියලා අපි ඒවට කියන්නේ. Right? What do you call them? Convectional currents. That's what you call them. එතකොට you have to know this is the procedure for convection. Convection කියන්නේ මෙන්න මේකට. So this is how heat is transferred through air and liquids. හරිද? Okay. So what I want you to do is, first of all, I want you to draw this image. Don't write down convectional currents කියලා. Convectional currents එක නම් mark කරගත්තර කමක් නැහැ by drawing an arrow like this. But this density relationship, don't write it down. Fireplace එකයි convectional currents එකයි විතරක් අඳගන්න. I'll send you an image. So for those who are watching the recording, the note is in the order whatever I have drawn in the board. If it is not clear for you on YouTube, the note is there in the order in our WhatsApp group chat. So refer to that if it is not clear in YouTube. It should be clear if you increase the resolution, because I am doing this in 4K 60 fps. Now what we are going to do is we'll write down a note for this convection process. Okay, so in the note, the first point you write down initially, so write it in point wise. Okay, write it point wise. Initially, air particles which are right on the top, which are right at the top of the fire, is going to get heated up. Which are right at the top of the fire is going to get heated up. Then you write down next point, then their volume will increase. So what is this there? There means the particles which were right at the top of the fireplace. Okay, then their volume will increase. Then the third point you write down, from the equation, write this equation now, D equals m over v. From the equation D equals m over v, when volume increases, density decreases. Density decreases. So where were we only? Again, D over mv, we wrote density. What was the last thing that we wrote?
From the equation, that equation.
Alright. From the equation D over m over D equals m over v, density is decreasing, right? Then you write down density decreases. After that you write down, this makes the heated particles to go up, and the colder particles to come down, and the colder, more dense particles to come down. Okay, and the colder, more dense particles to come down. This makes the heated particles to go up and the colder, more dense particles to come down, creating a current, creating a pattern. So it will be repeating by itself. Okay, again those hot particles will go up, so you're creating a pattern. creating a pattern. This motion is called a convection current. This motion is called a convection current. This motion is called a convection current. My God, who's calling? Right. So it is called a convection current. And finally, you write. So not finally write down. You finally understand. Now you have to understand this is how energy is transferred through gases or liquids. What I have given is a scenario for a liquid gas. In the exam, they might ask you for a liquid, so the same thing you have write down with liquid particles. There, liquid particles would go up, these would move down. Okay. So my convection currents is very useful. Right? Okay. Then next, write down the last way to transfer energy, thermal radiation. Thermal radiation. Radiation, right? Radiation. This is the last way to transfer this energy. Hurry. So what happens during thermal radiation? Okay. You have to understand all objects, no matter whatever is the temperature, all objects emit radiation. All objects emit radiation, no matter whatever the temperature is. They emit radiation like this to the surroundings. Okay, they emit radiation. However, there's one thing: the more hotter the object is, more the infrared radiation it is radiating in a given time. You have to let that sink into you, right? So all objects emit a radiation. However, no matter the more hotter the object is, more amount of radiation it will emit. So there's something with colors and the shininess of the surface which this radiation depends on. So you have to understand that these black color and very dull objects, dull means dark in color, okay, black and dull objects are the best at emitting and absorbing radiation. So this is a way of heat, transfer of heat. Okay, I'll tell it to you. You'll understand when I tell an example. Then shiny objects, white color and shiny objects, especially white color and shiny objects, they are the worst at emitting and absorbing thermal radiation. Now, for example, have you ever wondered those cricket matches? In those cricket matches which are played in the day, during the day, when the sun is there, because it's a huge ground, there is a sun, scorching hot. The players are playing. No? So why are they wearing? The cricket matches which are played on at daytime, they are called test cricket matches. So on those test cricket matches, why are the players wearing white color? Why? Because white color is the worst emitting and absorbing thermal radiation. It is the worst at emitting and absorbing thermal radiation, right? So the sun, you get heat from the sun through radiation, not the light, the heat from the sun. So if you are wearing a white color overall, what will happen? You will feel less heat. What if you are wearing a very dark, dull color under the sun? You will feel more heat. You will get more and more heat, right? However, the thing is, imagine you have gotten really hot, right? You have gotten like super hot, and then you wear a white color shirt, and then you wait. Then the hotness will increase. Why? It is not a good radiator of heat. It won't let heat out. So especially in those thermal flasks where you can store water, hot water, and keep it hot for a long time. If you have seen the inside surface of those thermal flasks, It is not white, no. But you must remember it is shiny, right? It is silver in color. It's a light color. It is shiny. What does that do? It will help retain the heat. So heat won't be emitted out by radiation. That you have to keep in your mind. Okay, right. So there is a small note. So it is also a way of radiation. Okay. So this is it for radiation. Let's write down a small note under this radiation. So the only diagram that you have to draw is this. But before drawing it, under radiation, write down all objects emit infrared radiation. So this thermal radiation is actually an IR, infrared. So you won't know what is an infrared radiation. You will be learning that under unit 3. Okay. So write down all bodies, no matter what temperature, emit infrared radiation. Emit infrared radiation. Emits radiation. Next point. The hotter an object is, more radiation is radiated in a given time. More radiation is radiated in a given time. Then, sorry, just because we have to draw something, can you draw this diagram? Right, first of all, draw that diagram. Okay. Done? Draw that diagram first of all. Right. Now, the next point, what you have write down is, after drawing this diagram, you write down black and dull objects. Black and dull, okay? Black and dull objects are the best at emitting and absorbing thermal radiation. Black and dull objects are the best at emitting and absorbing thermal radiation. Are the best at absorbing and emitting thermal radiation. Next point, you write down white and shiny objects. White and shiny objects are the worst at absorbing and emitting thermal radiation. Are the worst at absorbing and emitting thermal radiation. So if we want to keep the temperature of something without it going out, we should use a white and shiny object. If we want to absorb more temperature, we should use a black and dark color surface. Okay, right. So once you have written it down, what we are going to do next is we'll be writing an example combining all these 3 energy transfer methods that you learned now. So what are these 3 energy transfer methods? Conduction, convection and radiation. So next subtopic, you put a subtopic, conduction, convection and radiation in a mug of coffee. In a mug of coffee or a mug of tea, right? Coffee cup, okay? Conduction, convection and radiation in a mug of coffee. So we'll be combining everything that we learned under conduction, convection, radiation, and we'll be learning how to apply it in the exam using a single scenario, single example. So in the exam, you will be asked to explain this conduction, this convection, especially convection, okay? Especially what happens in convection, they have asked multiple times, and even radiation, okay? So make sure you get this into your mind. So in the last week, I did all the easy parts of the lesson. I did all the equation parts of the lesson. Now these are the theory parts, okay? So keep that in your mind, right? So let's get on to how to identify the conduction, convection and radiation of a mug now. Right, so let's see. You have to understand, for a mug of coffee, energy is transferred by radiation from the surface of the mug to the surroundings. So I'm going to draw it for you now. This is a coffee mug. Something like this, no? Something like this. There's the handle. Energy will be transferred by the coffee mug to the surroundings, like this, to the surroundings through radiation. So write that down. Draw a coffee mug like this and mark these points. Energy transferred to surroundings by radiation. This side also same thing, but I don't think you'll need to draw this. Generally, you can't see, no? So you should let me know those things. Can you see this now? Got it? This is what you need to do. Then, what is the next thing? So, through the surroundings, from the mug, it is transferred. How is the heat of the coffee transferred to mug? Okay, so let's just say this is sitting on a table, on a not a table, on a book. This is a book. We have kept the coffee mug on the book. After some time, if I take away the coffee mug, we can see, not we can see, we can feel that the book is hotter at the part the coffee mug was. So what does that mean? The book was heated up. This book is heated up by conduction, oscillation of particles, right? So the coffee inside first is initially hot. From the coffee, by the vibration of coffee particles, the mug, which is made out of porcelain or something, that also gets hot. From the mug, through conduction, the book gets hot, right? So here we can say energy transferred to the book, by conduction. Okay, so now we have discussed for radiation, we have discussed for conduction. What is it for convection? Convection වලට මොකක්ද තියෙන්නේ? What is it for convection? Yes, correct. The heat which is going up from here. ඇතුළෙත් වෙනවා from the, because inside it can't happen actually because we are not heating it up, but from the surface it is happening. From the surface it is like this. This is how the convection currents are acting in this manner. So here we can say steam. What? Steam. Steam rising away from the cup, from the mug actually, no? From the mug to the surroundings. Right? You have to know that. Okay, so that you have to know. Then that is it. I will send an image of this as well, just in case. So those who are watching the recording, again, if you can't see it clearly, go check your group. All the images in the order I have sent to the this thing. So also you have to know that there are a couple of practicals which are associated with this lesson, and we have unit 1's practicals as well. We'll take a separate day and do all of this. So here there is only 2 practicals in this lesson. Unit 1 also 2 practicals. They are not really required for the exam, but then I'm just giving it to you just in case. You never know. No? Okay. So now conduction, convection, radiation part is over, right? Write down reducing energy loss. Reducing energy loss. Reducing energy loss. Reducing energy loss. So tell me, what is this energy loss? What do we call energy loss? Think about it. Okay. So now what I want to do is, if you have written the topic, reducing energy loss, underneath that we'll just try to understand. So okay, before writing we'll try to understand what is this reducing energy loss is. So you also listen occasionally. Right. So energy loss means, can you remember under power in efficiency and especially in Sankey diagrams, right? We learnt about energy going out. We had useful energy and wasted energy. So energy loss means the wasted energy of a system after we from the input energy that we give. So that energy is wasted, it cannot be used. So we associated with this conduction, convection and radiation in this coffee mug example, we saw that energy is, once we keep a coffee mug like this, it won't just stay hot for a long time, right? It will be at room temperature after a very short period of time, maximum 30 minutes. By 30 minutes, it is at room temperature. How can we increase that time and how can we reduce all of this energy going out of the this thing, going out to the surrounding environment? How can we reduce that energy? We can use something called insulation. So we learned about insulators, that I know. Do not jumble insulators with insulation. Insulation means something like a thermal flask. What do you call thermoflasks? So what happens if you have seen, you must have seen those flasks at your house. So once your mother heats up water in the kettle to make tea, some water will remain. No? So most of the time, right, they'll just keep the water and use it as drinking water. But sometimes they'll put that heated water into the thermoflask so that it will stay hot. If you are sick, so if let's say you get sick, then you will be drinking hot water from that thermoflask. You won't need to heat up water every single time you want hot water. So it's an advantage. Also, now they have these small coffee, like small mugs, right? Small mugs, they are like we can store hot or cold water for a long period of time without them losing their hotness or coldness, right? So that is known as insulation. Also, in those foreign countries where there is winter, they wear these overcoats. No, that is also a type of insulation. When the surrounding is cold, we also feel the cold. So what happens? Our body temperature is losing. Even though our body temperature is 36 Celsius, we still feel a lot cold. But if we put those very warm coats, warm means very fluffy, large coats around us, our body temperature will be retained. So we will feel a bit warmth. That is the reason we are using something like insulation. So to prevent or to reduce this energy loss, to reduce energy going or energy wasted to the surrounding environment, we are using insulation. Okay. So by insulation, insulation should either reduce conduction or convection. It will reduce We can't obviously reduce the radiation. No, there's no physical factor to reduce the radiation. That is out of the picture. However, we can control and reduce the conduction and convection. Okay. So therefore, because radiation that can be controlled easily. Sun is situated in space. No, we are getting heat from the sun, but there are no particles. There are no particles. How we are getting heat from? Right? It is space. In space, there are no particles. We haven't got any particles, no. So, in space, how are we getting the heat from the sun? Still, it's not by conduction anyway. For conduction, you need particulate matter. So, we are getting heat through radiation. So, we can't really possibly decrease the radiation. We have to control conduction and convection. Okay, right. So now what we'll do is we'll just write down under reducing energy loss. You write there are many situations. There are many situations where energy transfers are actually unwanted. There are many situations where energy transfers are actually unwanted. Under that, you write down these three scenarios that I'm saying. You write down these three scenarios that I'm saying. Number one, keeping a house warm. So, especially in foreign countries, when there's the winter, you have to keep the house warm. For that, we have reduced the energy loss from the house to the surroundings. Right? Number one, keeping a house warm. Number two, keeping a drink hot or cold. Keeping a drink hot or cold. And the last one, dressing to stay warm in cold weather. Dressing to stay warm in cold weather. Right. So we learned about the needs for insulation to occur, the needs to reduce energy loss. We can't have energy going out of a house during winter, no, right? We can't have a drink getting cold like that, and also we have to protect ourselves during a cold season, right? So how do we do that? We have to reduce the convection and conduction. Now you write down reducing conduction and convection. Reducing conduction and convection. Right? Reducing conduction and under that you write down to reduce energy transfers by conduction. To reduce energy transfers by conduction, materials with low thermal conductions. Materials with low thermal conduction, such as insulators. Materials with low thermal conduction, such as insulators, should be used. Materials with low thermal conduction, such as insulators, should be used. Now you should get into your mind, in the first couple of minutes we learned about conductors and insulators, right? So now recall, plastics, rubber, those types of things should be used instead of conductors to reduce. So then we will be able to reduce the conduction. Okay. To reduce energy transfer by conduction, materials with low thermal conduction, such as insulators, should be used. Okay. I'm sorry. Now we were talking about convection. So under convection, to reduce the convection, we know in convection, convectional currents are formed. So if we are able to limit the formation of the convectional currents to some extent, or to reduce the convectional process, we should be able to reduce the loss of energy to the surroundings due to convection. So what should we do? You write down to reduce energy transfers by convection. To reduce energy transfers by convection. reduce energy transfers by convection. Convection currents must be prevented. Convection currents must be prevented from forming. Convection currents must be prevented from forming. So how can we prevent it? For this coffee mug, if I keep a lid on top of it, which will close the mug completely, then it will prevent the convection current from floating and the steam going out. So we'll be able to retain the heat in the coffee for a little bit more time. Right? So keep that in your mind. Okay? Right. Right. Now we have learned how to reduce conduction and convection. So that is how we can use insulation to stop energy from going outside. So when we are doing questions, we'll learn more related to this reducing energy loss. So we'll get questions related to this energy loss. And when I'm doing questions related to this lesson, I'll tell you how to tackle those questions easier and better. Okay? Right. I think this microphone is switched off. Okay. So now what we have to know is next we'll be learning about something called energy resources. However, students, here energy resources it's nothing flashy, nothing too hard to understand or comprehend. We are going to learn about renewable and non-renewable energy resources. So it's more like an environmental lesson, a lesson about environment. And what I'll be doing is I'll just be going through these energy resources. Then I will send you a note to the group of ours. So now as you can see, I have sent you the note to the order. Initially I've sent you the note of conduction, and then I sent you the note of convection. Under radiation we didn't write anything that much, we didn't draw that much, we just drew a square and radiation going out. However, now after that I sent the mark as well. Then all that we did was the writing down parts, right? Now after this, once you are watching this recording, you will see a note in our group. So first of all, listen to what I am saying here, and then while listening you refer to that note, and then you copy that note in your writing book. That's it. Okay. So these things I'm not really like, they are not really asking these questions that much, okay, in the exam, but then just in case I'm giving you a note. However, if this was an individual class or something, I won't be asking you to write this down, but since it is a group class, we never know what they can ask in school. In schools they ask this. If especially if the for the fourth lesson, if they give you a separate paper like a monthly test for the fourth lessons, about 30% of the questions will be from this part. Okay, right. Okay, so now let's get on to it. Under this, write down, not write down, you have to anyway write down the topic energy resources. First of all, listen up. There are something called renewable and non-renewable energy resources. So what are known as renewable energy resources? Renewable means what? An energy source that is replenished at a faster rate than the rate at which it is being used. What is known as replenished? Filled up filled up, replenished, like respawned in games. You are like spawning, no, like that. So these energy sources, they will never go out. Like they are renewable. They can be used always. What are some examples? We have got solar panels and those things, right? Solar panels, geothermal energy, tidal energy, then wind, hydroelectricity, those things. Then what we have got is non-renewable energy sources. What are non-renewable energy sources? Non-renewable energy source means energy sources, if we use them at one point, they will run out. Renewable energy sources never runs out. You have to keep that in your mind. So now I'll be sending you the note for these renewable and non-renewable energy sources. Right. So if you check your group, you'll find the note there. So Senoli, you also must write down this in the given order that I'm sending. Okay. Then this is the definition for the renewable energy source. The definition that you have got, and then after that we have got the examples for these renewable and non-renewable energy sources. These are actually renewable energy sources, and then next what I have sent is the non-renewable energy sources. So some non-renewable energy sources are what? Fossil fuels, and fossil fuels are one of the thing. Oils like LP oils, like what do you call that type of oil? Not LP oil. Samuel, do you have any idea what do you call it? අපි කියන්නේ what you get on those barrels in oil mining sites, that what you call it? Large barrels, black oil, I think it is called black oil. It is anyway black in color. Okay, that is refined, that is sent through a purification process, and then only we are getting those yellow color oil. Okay, so this is the note for renewable and non-renewable energy sources. Then they have given us, like, these so we learned about renewable energy sources, no, in the examples: wind energy, geothermal energy, solar cells, those things. Next, what you need to understand is how it actually functions, right? How it actually functions. So those things I'll be sending it to you as a note. So what you have to do is you just have to copy those down. Okay, I mean, that's the thing. You just have to write it down in your writing book. That's it. After that, the lesson will be over. Lesson number 4 is over. And if you look at your textbook, okay, student book, if you look at your student book, you will have something called comparing energy resources. That is basically saying the advantages and disadvantages of the energy resources that we talked about. So commonly, okay, both renewable and non-renewable, there are advantages and disadvantages. I'll just be going over that as well, and I'll give you a table for that. So once you have written it down in your textbook, this lesson will be over. Okay, so anyway, I'm going to be I'll explain you about wind energy. So wind energy, have you seen those large turbines, wind power turbines, which are rotating? That is what is used to create electricity through wind. So when the wind is blowing, those turbines are rotating, and due to the rotation, kinetic energy is produced. That kinetic energy is converted to electrical energy through the generator, which is placed inside, and then sent to the national power grid. Okay, so I'll just send the note as well. It is wind. I mean, roughly you have to draw a wind turbine. So I'll just take a wind turbine from one of the internet images, and I'll just send it as well. So just roughly draw it. Okay, no need of fancy drawings. Wind, and then wind is used to turbines directly, and then from the generator. So this has the procedure on how wind is being this thing. Then let's say wind turbine Sri Lanka. Just roughly draw one wind turbine image. Okay, something like this. I think this is better. Yes, so wind turbine. So this is energy by wind. Okay, right. Senoli, for you, Can you first of all write the up till until non-renewable energy sources? Okay. So now, anyway, what we have is we learned about the wind power, how wind is converted to electricity. Next, what we have is water. That is, so converting water into electric power is known as the hydroelectric power. Hydroelectric power. So then there, this is the note that I am sending it to this thing. So what happens? I am going to send a picture and I will be sharing the picture on the screen as well. So look for a bit at this picture. Hold on, I'll share the screen. Right. Click share screen. So if you look at this image, you will see a reservoir here. This is a reservoir, and then there is a dam, right? Then this is the water which is coming down, and there is a turbine situation. This is water inlet, means they have created a separate entrance exit for a water to go, and they have put a turbine here, as you can see, right? Then what happens? This turbine is rotated. That kinetic energy is converted to electrical energy in this powerhouse. So, what type of energy does the water possess when it is at the top of the dam? Oh, it is coming from the top. No, the water has potential energy, and that potential energy is converted to kinetic energy when the water is flowing from here. Then what happens? This turbine is rotating. It is rotating. After that, that energy, potential energy, becomes kinetic energy. Kinetic energy becomes what type of energy? Kinetic energy becomes electrical energy. That's what you have to understand there. Okay. On as well. Okay. So that diagram that I just showed you, I have sent that as well to our group with the relevant note. That also you must copy. Okay. Right. So next type of energy that we are producing or sourcing is what do you call geothermal energy. So what is this geothermal energy? Geothermal energy means what? Mokada. Geothermal energy means sometimes there are hot water or steam inside the earth and lava. There is lava inside the earth. So what they are doing is they are digging the ground to very high depths and putting pipes. Then they are utilized. So through lava, what are they doing? There are hot rocks and lava, steam, and everything in the ground. They use water. They put water and they produce steam out of that hot lava. Using that steam, they rotate turbines to generate electricity. So they are known as geothermal resources or geothermal energy. So then the turbine when it is turning, the turbine will have kinetic energy. That kinetic energy is converted to what you call electric energy through the power generator, right? So I'll send you the note for the geothermal resources as well with a small diagram. Now the diagram that I sent to the power, not the sorry, the hydroelectric energy, that diagram also roughly you can write down. Here for geothermal energy also you can write down the diagram roughly as well. Okay, right. So here the sound might be not a bit clear. My mic's battery ran out. That is the thing. So this is the camera's microphone. That's the reason. Okay. Anyway, next type of energy is solar panels and solar heaters, right? So that you obviously know, that is a very popular type of renewable energy that we learn in Sri Lanka. Solar panels, there was a trend as well in around 3 years ago when there was the power cut. Huge trend to put solar panels in every house, so most of the people bought it. Yeah, and it is good. It's a very good renewable source of energy. So Sri Lanka is a country which is getting sunlight 12 hours a day now. So I think it's the best if we utilize it. But these solar panels, they cost a lot. That is the downside. But other than that, it's a very renewable energy resource. The sun is going to come up every day, right? Unless it is the, what do you call, ending of the world, right? Unless it is the end of the world, the sun will come up the next day. So it is renewing. It is renewing every day, right? Okay. So those are the solar cells, and solar cells use the electromagnetic radiation or the heat from the sun directly to generate a current, right? So that also I'll send you. Just under solar cells, just draw a small solar panel, right? You can draw a solar panel something like this. I'll send you a nice diagram. Just roughly draw a solar panel. So there is the sun, there are the clouds, and there are some solar panels, right? Right. Okay. Then now what? After this, the last part. No, there's actually two or three more. Fossil fuels. They are non-renewable energy source. Why? There is a certain amount of coal the world has no. So that is reducing by the day. So there will come one point in the future, coal will is not no longer there available in our planet. So then we won't be able to use coal to produce energy, produce electricity. How do we use coal to produce electricity is what we are going to learn now. So fossil fuels, if they say fossil fuels, it's mainly coal, okay? Coal and LP gas. Gas means what you get in this gas cookers, none of those things. So fossil fuels, they are combusted. They are combusted to heat water and produce steam that turns turbines. So that is what these coal power plants do. Coal power plants. So if you look at Noracholi, there's a area called Noracholi in Sri Lanka. You might have not know it. If you don't know it, then you know it today, right? So in Norachole, they have this coal power plant. So this is the process that they are following. They are burning the coal. They are using the heat that we can get from the coal to heat up water, and that water will produce a steam. That steam is used to rotate turbines, and that rotation, that kinetic energy that we get from the rotation, is converted to electricity by sending it through a power generator, right? So for fossil fuels also, now it is the same. So now you kind of understand what's the scenario here, right? Usually we somehow rotate something, it will create an energy that is converted to electricity using a power generator. That is what we are doing, okay? Okay, so for fossil fuels, I won't send you a diagram. There's actually the same thing, no point of drawing a diagram there. And those are some major ways to convert this thing. And also you should know a bit of these solar heating systems that you get on houses, on the roofs of the houses. So they also same thing, they use sunlight, the heat from the sunlight, to heat up water that we use for bathing, right? Those things as well. And then yeah, think that is enough. Yes. So that is the so I've sent you all the notes to our WhatsApp group. You should write down those in the order that I've sent to you. Okay. Right. Next, what we have got is, I told you, write down comparing energy resources. That is the subtopic. Under that, advantages and disadvantages of energy resources. So now Senuli, don't leave space or anything. I'm sending everything in order. Whatever you should write down in our WhatsApp group. So students, those who are watching the recording, slowly go through your WhatsApp group one by one. Okay, WhatsApp group එක මම දාලා තියෙන messages one by one slowly go through කරන්න. So first of all, I've sent you renewable and non-renewable energy resources topic එක. Under that you should write down those examples for renewable and non-renewable resources. Then I've explained to you how wind energy is produced and converted to electrical, how hydroelectric energy is used, how geothermal energy is used, how solar cells are used, and how fossil fuels are used. ඒ වගේත් respective notes in that respective order that I just said, I have sent. Then now I am sending you the topic. I have sent you the topic already, comparing energy resources, and under that තමයි ලියන්නේ advantages and disadvantages of energy resources කියලා. So what are these advantages and disadvantages of energy resources? No. So that will compare. There is a table that I will be sending to you. You have to draw that table. Right? It's going to be a long table, a very large table. Right? It is not your average table. So under that, basically, we are learning about this advantages and disadvantages of energy resources that we talked about before. So let's, for example, I'll just explain one of them to you. You will be able to manage the rest of them. Like I'll explain two or three to you. You should be able to manage the rest of it on your own. Okay. All right. So fossil fuels. If you have to take fossil fuels, what are the advantages of fossil fuels? They are very reliable. If we have coal, if we have gas, we can heat them up and produce this thing. Turn the turbine, produce current. However, what is the disadvantage? Environmental pollution. When you are burning coal, this gas go up, no? This black color gas that contains carbon dioxide. It is a greenhouse gas. I mean, those things I think you learn in chemistry. Global warming is related to global warming. If you don't know what is global warming is like making the earth more heated. Think of it like that. If you want to know more, you can go and watch a YouTube video, guys. In YouTube, they are nicely explained global warming. You don't need global warming in your syllabus. I think for chemistry, you learn about global warming. Anyway, carbon dioxide is emitted to the earth, and just know that emitting carbon dioxide make the earth more inhabitable. That means it will make the environment more hotter, right? That's what you have to understand. Then if we were to take something like wind is a renewable energy source. So wind produces no pollution. The advantage is it produces no pollution, no carbon dioxide, and the wind power station, they are cheap to build relatively. Okay, relatively they are not cheap, but relative to others they are cheap to build and easy to maintain. However, what is the disadvantage? It is non-reliable. We don't know exactly when will wind come up. අපට ඕනලාට wind එන්නේ නැහනේ. Right? Wind will come when wind wants. So we don't know exactly when we will be able to produce that power. Right? Therefore, that is the disadvantage. It is non-reliable. Then what about tidal waves? Tidal waves means, if you have heard of high tide and low tide. High tide means at night the sea rises up. In the morning the sea goes down. High tide, low tide can make. The tides are the advantage is tides are very predictable. So tides කියන එක හරියට දන්නේ නැත්නම් tides mean in the sea at night the moon comes up, no, because of the moon's gravitational pull the sea is going to rise by a bit. එහෙම හිතන්න. Right? Then tide means tides are very predictable. Anyway, they are happening, always they are happening, so that is the advantage. Tides are a renewable energy resource. Okay. However, what is the disadvantage? Only in a few selected locations we can do. Let's say a European country which is situated in the middle of Europe. Do they have sea around them? No, so they can't use it. Sri Lanka is a very nice country. People don't understand. See, we got ocean around us now. We have to take use of that. We have to utilize the ocean. Got it? So you keep those things in your mind. So I've sent you the table that you have to draw as well underneath. HRI. That is the note. That is it. That is it for this thing. And that is the end of the lesson as well. Okay. So what you must do is, first of all, copy this note. Then after this, I'll send you a question paper to the group. You'll get the question paper so I don't know the day that you are seeing this recording, but today's the day that I'm recording this is on a Tuesday. So by tonight, okay, Senoli, I'll send you a paper which I made for this lesson, for lesson number 4. There are going to be, I'll put around 20 questions. Okay. So what I want you to do is, I want you to take a printout of this paper. I'll specifically send a voice recording as well with the paper. You have to take a printout of the paper and bring into the next class. The reason is I can give you a printout easily. It's not that much of a big issue for me. But then this Sunday I won't be able to do class for you. So listen carefully. Okay? Tell it to your parents if your parents are not there. Otherwise you will end up bringing them here and I won't be there at the house. I have to go to a important what do you call journey. It's a little bit long. It will be like 10 a.m. when I come to back to Colombo. I'll be out of Colombo. So on Sunday, I don't think we'll be able to do the class. I'll discuss and tell you a separate date for the class, and we'll have to cover it up anyway because before the exam in license, we have to cover it up as well. So you have to get the paper done anyway. Sometimes, most probably by next Tuesday, the same time, 5 to 7. I'll put this class next week as well because to cover up for the Sunday class, I miss Sunday class. So then that also I'll still send you the recordings like this. So next Sunday, remember, next Sunday means what's the date? So today is 11th. 16th of Sunday, 16th of November, no class. Okay, no class will be held. The Tuesday night class will be held as usual the next week as well. So today I am unable to do it, but the next week we'll have the class. So those who are looking this recording, make sure to get that paper printed. Try to complete the paper. I've given you everything related to this what do you call lesson, and that is it. Okay, so what I'll do is I'll send you the paper tonight. Make sure you get the printout of it and complete the paper. The next day that we are meeting again, we'll be discussing the paper. Okay, so that is it. Goodbye.